Good morning. So here, next roll of size, roll of base size. So roll of base in Sedgwick-Hoffman elimination, roll of the base. So here base size is the base size depending on the size of the base. One is maybe present formation of the higher quantity or maybe formation of the lower quantity. Nothing but the so second rule is the size of the base. Size of the base. So as the size of base increases, as the size of the base increases, the base prefers to attack more exposed hydrogen and resulting in the formation of lesser amount of the Sedgwick product. So as the size of the base increases, the base prefers to attack more exposed hydrogen means less substituted hydrogen and resulting in the formation of lesser amount of Sedgwick product. As the size of base, as the size of base increases, as the size of the base increases, the base prefers to attack. The base prefers to attack, attack, prefers to attack more exposed hydrogen, more exposed hydrogen, more exposed hydrogen, and resulting in the formation of in the formation of lesser amount of Sedgwick product. So lesser amount of the Sedgwick product. So here you are using the base means Sedgwick product is minor, Hoffman product is major. Here base, here Hoffman product HP, Sedgwick product SP. Here Hoffman product, here Sedgwick product. Okay. So we are using the ether oxide as a base. Base is a ether oxide. So ether oxide base. So Hoffman product only 25, 29 percentage, and Sedgwick product is a formation 71 percentage. You're using the base is a S smaller base is using. So which is the Sedgwick product 71 percentage, Hoffman product only 29 percentage. Okay. Now here instead of this one, you're using the tertiary butoxide. So here tertiary butoxide is a base. Here bulky. So here what happened? Here steric crowding arises 72 percentage Hoffman product and 28 percentage is a Sedgwick product. So this is a tertiary butoxide. So in this tertiary butoxide, one of the group is the methyl is replaced by the ethyl. So then a steric crowd is increasing. Therefore, Hoffman product nothing but less substituted is a 78 percentage, and this is formation. Sedgwick is a only 22 percentage formation. Next to here what happened? Here all are the ethyl group. C2H5, C2H5. Here this one. So this is a base is using. So this is mainly formation Hoffman product is a 89 percentage. Here only 11 percentage of the Sedgwick product. So Sedgwick product nothing but more substituted olefin. Hoffman product nothing but less substituted olefin. So the size of the base increases. The Sedgwick product formation is decreases, and Hoffman product formation is increases. On conclusion, as the size of base increases, as Hoffman product HP means less substituted olefin, less substituted olefin major formation increases and Sp more substituted olefin formation decreases. Next, Hoffman rule. So, Hoffman rule. Here, Hoffman rule. So, according to Hoffman rule, in the elimination reactions, according to Hoffman rule, in the elimination reaction, mainly elimination reactions of the positively charged species, say as a quaternary ammonium salts, it leads to the less substituted olefins as a major products. So mostly here, quaternary salts is involved in the here Hoffman eliminations. Quaternary ammonium salts, quaternary phosphonium salts are involved in the yes Hoffman elimination. Here Hoffman elimination mainly here major product is a less substituted olefin. So here mainly involvement in the yes quaternary ammonium salts, quaternary phosphonium salts. So these are the mainly involved. Yes, according to this rule, in the elimination reactions, in the elimination elimination reactions, in the elimination reactions, in the elimination reactions of positively positively charged quaternary ammonium salts, quaternary ammonium salts, quaternary ammonium salts, salts produce produce less substituted cuted less substituted salts in the presence of base in the presence of base to produce to produce less substituted olefins. Less substituted olefins. Less substituted olefins are major product. Major product. So let's substitute olefin major product. So in the branch of the year which is using in the branch of base here mainly involvement the positively charged quaternary ammonium salts. Quaternary ammonium salts cousins of this here formation of the less substituted olefin is a major. So this is the S which is there here product this is the product is called as a Hoffman product. Hoffman product. Major product is which is the Hoffman product, nothing but the less substituted product. So in the elimination reactions, more beta acidic hydrogen is abstracted by the base. In this Hoffman elimination reactions, more acidic beta hydrogen atom is abstracted by base. More acidic beta hydrogen is abstracted by the base. Okay. So here in this elimination reactions elimination in this elimination reactions most more acidic hydrogen is abstracted by base. Here, more acidic hydrogen abstracted by the base. Nothing but base is taking more acidic hydrogen. More acidic hydrogen. So see an example. Now see the example. So here H2C having H, CH2. Here quaternary nitrogen having CH3. Here CH3 with the positive charge. And here CH2, here CHH, here CH3. So this is a with respect to nitrogen, here alpha carbon, beta carbon. So this is the one of the beta hydrogen. With respect to quaternary salts, here alpha carbon, beta carbon. So like as alpha dash, beta dash. So this is a beta hydrogen. So in this case, we are using the base, for example, using the ethoxide ion. That's it. This is a base. So base is mainly take the acidic proton. Why these are the acidic centers? A nitrogen, high electronegative nitrogen gives positive charges unstable due to loss of its electron density that is coming from lone pair of electron. That's why we take the bonding electron density. Yes, here bonding electron density, this bonding electron density takes towards itself. So here it is exhibiting the here minus I effect. So in this situation, so what happened? One of the here what happened? The carbons is a here carbon, the bonding electron density decreases. So therefore the hydrogens makes the acidic nature. Hydrogens makes the acidic nature. So in this case, here which is the more exposed? So more exposed is this one compared to here because here what happened? One is a steric crowding due to this methyl group, and also your acid nature is less because so it is exhibiting the nitrogen minus I effect. The bonding electrons is shifting. This bonding electron density is taking, but here taking, but here only donating, but also this deficiency can be fulfilled by this one. This is alpha carbon, alpha, here beta dash, here gamma dash. Here only alpha, beta, gamma hydrogen is not there. So therefore here makes less acidic. Less acidic. Here more acidic. More acidic. So this more acidic and it is a more exposed. More exposed. Exposed beta hydrogen. More exposed beta hydrogen. The base is preferentially take the more exposed hydrogen or more acidic hydrogen. So this is a more exposed beta hydrogen, here less exposed beta hydrogen, less exposed beta hydrogen. So that's why the base is preferentially abstract the more exposed hydrogen. And this elimination, so the bond diagram shifting and this is moving to here. So then what happened? Here resulting is a H2C double bond CH2. Yes, ethylene. Ethylene is a less substitution, no substitution. So less substituted, less substitution is a major, and here another one is a water pin, more substitution olefin. More substitution means this hydrogen is lost, a double bond formation. This can be eliminated. So that is a H2C double bond CH3. So here what happened? Here mono substitution. Here non substitution. Non substitution is a less substitution. Mono substitution is a more substitution. Only comparison relatively. So therefore this is major, this is a minor. This is a major olefin, this is a minor olefin. Here major is mainly 98% is formation. Here 98%. Here minor is a only 2% formation. So this is a which called here Hoffman product. This is a HP product. Here SP product. SP means Serger product. Here Hoffman product. Please take a screenshot. Now I am explaining the mechanism. So see the mechanism. Mechanism for this one. See here H2CH, H2CH, here CH2, here nitrogen, yes, this CH2, here CHH, CH3, here positive charge. So then what happened here? Here alpha carbon, yes, is beta carbon. This is a beta hydrogen. The base is mainly approaches to this beta hydrogen, and then the bonding electron shifting. This is moving to here. So then resulting which is formation. So here double bond formation. Then that is HC to double bond CH2, and the remaining which is formation here CH3, CH3, here CH2, here CH2, CH3. So this is the lone pair of electron retention. Here tertiary amine. Here which is there? Quaternary ammonium salt. So this is a olefin. So this is which is the less substitution. Less substitution olefin into the major. Why? It is a preferentially is abstracted by this proton. So otherwise another the minor product. So this is which is a Hoffman product, HP product. So see the next one, because here hydrogen is a more acidic. Here next one more acidic proton is taken. So here what happens? The rate is also fast. So now see this one H2C H CH2 N CH3 CH3 having positive charge with CH2 CH3 NH. This hydrogen is a less acidic, less acidic, less acidic, and less exposure. The base is using ethyl sodium base. So this is approaching to this proton. The bonding electron shifting. This is moving to here. So, but it is less acidic. Here, attacking to less preparation, less preferential attack. Here, more preferential attack. So therefore, that's why the reaction is slow. So what happened? A double bond formation, that is a H2C double bond CH CH3 is a minor. Which product is the SHF? So here this is remaining is what happened? Tertiary amine formation. So that is a H3C CH2 N 1 pair CH3 CH3, which is the tertiary amine. So which is the major here? How much percentage formation? 98 percentage formation. This is only 2 percentage formation. So this is a more substitution, less quantity, and this substitution is formation is a high quantity. Please take a screenshot. So here mainly plus I effect of the methyl group decreases. This is the here mainly plus I effect is there. So more plus I effect here decreases the acidic nature of this beta hydrogen. So here less I effect of this hydrogen. So here more acidic. So therefore that's why base is preferentially abstracted this beta hydrogen compared to this beta hydrogen. So therefore this elimination is major and it is fast. The formation is the 98 percentage. So exception of Hoffman rule. Exception of Hoffman rule or Hoffman elimination. So here exception is mean whenever electronegative groups or electron withdrawing groups, like cyanide, carbonyl, carboxylic acid, ester, and phenyl, etc., are present at the beta carbon atom with hydrogen. Then this hydrogen becomes the more acidic. Hence, Sedgwick product is a major product. So when electronegative groups are electron releasing groups, are electron withdrawing groups, like as a cyanide, CO carbonyl, carboxylic acid, ester, amide, and phenyl, etc. The groups are present at the beta carbon with beta carbon atom with the hydrogen. Then the hydrogen becomes the more acidic. Therefore, hence Serja product is major and Hoffman product is a minor. So that is an exception for this one. When electron withdrawing groups are electronegative groups are electronegative groups electronegative groups like Cn, Cyan, CO, S carbonyl group either may be halide or ketone, acid or ester or amide or nitro and phenyl, dash, etc. are present at beta carbon of quaternary ammonium salts, the beta carbon, the beta carbon containing hydrogen is more acidic. Acid. In the presence of base, the elimination is preferred to result more substituted olefin as major. That is a Serja product. And Hoffman product is less substituted olefin as minor. This is a Hoffman. So this is the exception for the Hoffman rule. Hoffman rule exception: whenever electron withdrawing groups are electronegative groups, such as a strong electron withdrawing groups like as a nitro group, cyanide group, carbonyl group, carboxylic acid, or maybe ester, amide, or phenyl, etc. groups are present. Beta carbon of the beta carbon in quaternary ammonium salts. The beta carbon electron density decreases. In turns to the beta carbon attached to proton electron density decreases. The proton of the hydrogen makes highly acidic character. In the presence of base. Base is mainly take this highly acidic proton. This proton is sterically crowded, but it can be highly acidic. This can be taken by the base, and the resulting product is a more substituted olefin as a major. That is a instead of the Hoffman product, Serja product is major, and less substituted olefin is minor because less substituted carbon having beta carbon having hydrogen is less acidic when compared to more substituted carbon, beta carbon, hydrogen. So therefore, less substituted olefin nothing but the Hoffman product is a minor and Serja product is a major. So this is an exception for the Hoffman elimination or Hoffman rule. Please take a screenshot. So, for example, see the example H3C CH2 here nitrogen having two methyl groups with positive charge next to CH2 CN. CN is a electron withdrawing group. Okay, so this is a alpha carbon, beta carbon with respect to quaternary nitrogen. Here alpha dash carbon, beta dash carbon. Okay, so in the presence of base. So here beta dash carbon having hydrogen. This is a beta dash carbon. So this is also beta carbon plus having hydrogen. So this is a which is hydrogen, more exposed hydrogen, more exposed hydrogen is here less exposed hydrogen. But here what happened this hydrogen? So this is a what happened? Means tell me. So this is the bonding electrons is taken by this one. Here bond electron density is taken by this one, and also here taken. So what happened? Here resulting electron density decreases. This makes as the proton electron density is donated to here. So this is a what happened? More acidic character. More acidic character. More acidic character. So here what happened? Only here donating only one direction. Here two directions taking. This is quaternary nitrogen taking electron density from these carbons, and also cyanide takes the electron density from this carbon. So what happened? Here electron densities are more is present compared to here. Here what happened? Small electron density is there. Small electron density is there. Here more electron density. Small electron density because this electron density is taken by cyanide group as well as the quaternary nitrogen. Therefore, this hydrogen is a highly acidic character, and this is a less acidic character. Less compared to this one, less acidic character. Acidic character. Both are the acidic character, but it is a high acidic character because here presence of the electron withdrawing group or electronegative group. So therefore, this highly acidic character, the base is preferentially is taken by this proton, this beta dash proton, compared to this beta proton. Yes, due to your steric crowding also presents, but your steric crowding is dominated by the acidic character. So you have no steric crowding because you are more exposed. Your steric crowding is there. Base approaching to here, this causes and this quaternary ammonia is causes steric repulsion. But in this case, only quaternary nitrogen containing groups is causes repulsion, steric repulsion, but not other groups. So here due to steric crowding is there, here absence of steric crowding. But here acidic character is more, here steric crowding is dominated by the acidic character. Steric crowding is dominated by the acidic character. That's why the base is preferentially abstracted this proton over this proton. So therefore, the resulting what happened? The resulting is that, so here what happened? This is the elimination and this is the elimination here double bond and this electrons going to here. This is the major. So therefore, that is a H2C double bond CH here CN is major. So and here remain another one. The base is abstracted this proton. The bonding electron shifting. This is moving. Then formation of resulting is a simple olefin. This is a minor. So here what is there? One substitution is there. Here zero substitution is there. Yes. Here one substitution. Yes. Here zero substitution. So this therefore here which is product more substitution is a major. Here which is there more substitution. This is termed as a one substitution equivalent more substituted compound. Here zero substitution means less substitution compound. So less substitution, more substitution is a here Sergia product, here Hoffman product. So which is a major? Here Sergia product major, Hoffman product is a minor. So therefore, this is the exception of the Hoffman rule. Whenever beta hydrogen containing the beta hydrogen in the quaternary amino acids, so beta hydrogen containing the electronegative groups or electron withdrawing groups is present, the base is preferentially the electron withdrawing group attached beta carbon proton is taking, because the beta carbon having proton is highly acidic. So the resulting product is a more substituted olefin as major and less substituted olefin is a minor. So therefore, your major is the name mainly which is there. Your Sergia product is major and Hoffman product is a minor. This is the exception for the one of the exception for the Hoffman rule. Please take a screenshot. So this is taken, the base is taken here preferentially, and the base is taking this proton is a less preferential. So next, another one more concept. This is a pyrolytic elimination reactions or syn elimination reactions. Pyrolytic elimination reactions or syn elimination reactions. So this is a one of the yes in this elimination is catalyst or any reagent. Then mainly what happen elimination takes place at high temperature, mainly 200 to 400 degrees centigrade heating. Then your elimination is takes place. Therefore, the reactions are called pyrolytic eliminations. This pyrolytic elimination, the reactions are carried in the gas phase only. Pyrolytic elimination reactions is also known as a syn elimination reactions. Syn elimination reaction means the eliminating groups is mainly removed from the same side or same plane. In this case, in these reactions involves a cyclic transition state, which may be either 4-membered or 5-membered or 6-membered. Sometimes these elimination reactions are called EI elimination, intramolecular elimination reactions. So these elimination reaction, the pyrolytic elimination reactions are first order reactions. First order reactions. Mainly, the pyrolytic elimination reactions is given by the alkyl halides, esters, xanthates, tertiary amine and oxides. The pyrolytic elimination reactions is given by the alkyl halides, esters, xanthates, tertiary amine and oxides. These are involved in the pyrolytic elimination reactions. Pyrolytic elimination reactions. These are also termed as a pyrolytic elimination. Elimination or syn elimination. Syn elimination. Pyrolytic elimination or syn elimination. Okay. So here several type of organic molecules, organic compounds undergoes elimination reactions on heating without any reagent. Therefore, we call as pyrolytic eliminations. Several type of several type of organic compounds, organic compounds, several types of organic compounds undergoes elimination reaction, undergoes elimination reactions, elimination reactions, undergoes elimination reactions without using any reagent, without using any reagent. Therefore, therefore we call as pyrolytic eliminations. Pyrolytic eliminations. We call as a pyrolytic elimination. Pyrolytic eliminations also termed as a syn eliminations. These reactions carried out in the gas phase. These reactions are carried out carried out in gas phase. Carried out in gas phase. Gas phase. So these reactions involves cyclic transition state. Cyclic transition state. Cyclic transition state. Cyclic transition state, which may be 4 or 5 or 6 membered 4 or 5 or 6 membered is size. 6 membered size. So sometimes these elimination reactions, sometimes these elimination reactions called as EI means intramolecular eliminations. Intramolecular elimination reaction means within the molecule elimination takes place. So these are the mainly proceeding first order kinetics because only one species is involved. These are unimolecular reactions, unimolecular reactions, and first order proceeding first order kinetics. First order kinetics. Only single species involvement in the rate determinant step, that is the reactant species. Here, elimination reactions are this mainly elimination elimination reactions of elimination reactions of alkyl halides, alkyl halides, comma esters, comma xanthates, and quaternary tertiary amine oxide, tertiary tertiary amine amine oxide, tertiary amine oxide are involved in pyralitic eliminations. Yes, which is there mainly the substrates are alkyl halides, esters, xanthates, tertiary oxides. These are the sometimes called as a intramolecular elimination. This proceeding through 4-membered, 5-membered, 6-membered cyclic transition state. These are carried out in the gas-phase reactions. So here without reagent is using one species involvement. Therefore, it is these are unimolecular reactions and first order kinetics. So without reagent, without catalyst, without solvent, only reaction proceed at high temperature. The high temperature around 200 to 400 degrees centigrade. The substrate molecule here either may be liquid or solid can be converted into gaseous state or vapor state. Therefore, vapor state it is mainly here bond breaking, bond making takes place at the simultaneously. So therefore, this formation of a cyclic transition state. The main transition state is a 4-membered or 5-membered, 6-membered space. So this elimination is mainly involved the substrate molecular starting materials is the alkyl halides, xanthates, esters, and tertiary amine and oxides. So these reactions are also termed as a EI elimination reaction. So in this reaction, only reactant one species converts to product. So single species involvement reaction. So rate determining step involvement only one species. That's why the order of the reaction is one. So and here molecularity is one, and it is process first order kinetics. So first order kinetics units is the time inverse. Units of the first order kinetics tell me. So first order kinetics, the units for how much is there? Units is time inverse. That may be minute inverse, second inverse, day inverse, hour inverse, month inverse, year inverse. Please take this screenshot. Now, see the examples. So, example, alkyl halides. Alkyl halides. See here. So, this is a X. Here, X means chlorine, bromine, iodine, chlorine. So, these are heating around 400 degrees centigrade. So, what happened? These two are lost. So, what happened? It is proceeding through These two laws are the HX, the formation of the double bond. So next one, second one is the esters. So esters, so this is a Sahar's projection. So the eliminating groups are same side. Therefore, this is called as a syn elimination. Ester. So around these are using 400 degrees centigrade. So what happened? The bonding electron shifting. This is moving. This is taking. So then what happened? Last of the S RCOOH acid group. Then formation of the olefin or alkene. So then now see the xanthates. So xanthates. So est here O C double bond S here SME SME. So this xanthate, so this around heating 150 to 200 degrees centigrade. So when what happens, this temperature is goes to vapor state, the bonding electron shifting, this is moving, this is shifting. So then resulting is what happen, HS C double bond O SME, and this is the last, then this one combination. This is the xanthates. So this is unstable. So then what happen? This can be used to this methyl sulfide. So methyl plus S double bond C double bond O. This is formation. So this is the xanthates. Next, third one, fourth one, tertiary amine N-oxide. See here hydrogen, here ammonia, here methyl group, here O minus, here N plus. So this is taking proton, the bonding shifting, and it is lost. So in the presence of high temperature, 200 degrees centigrade. So here olefin S, here N OH. So this is a tertiary amine oxide. So here mainly involvement is the one is the which is the alkyl halide. Second one is the S esters. Third one is the xanthates. Fourth one is the tertiary amine oxides. So these are the elimination reactions. Thank you to all. Please take a screenshot.